Hey, welcome. Today, we're going to unpack a really simple idea, but it's an idea that powers so much of the digital world you use every single day. It's called a linked list, and believe it or not, it's one of the most fundamental building blocks in all of programming. To really get what this is all about, let's start with something you already know. Have you ever thought about your music playlist? You know, how you can just drag a song to the top or delete one from the middle, and the whole thing just works. There's no stutter, no big loading bar. Well, that's not magic. The secret is the super clever logic of a linked list. All right, so the absolute best way to understand a linked list is to picture it as a kind of digital treasure hunt. Seriously, forget code for a second. This is an idea that anyone can totally get. So here's how this treasure hunt plays out. You start at the very beginning with the first clue. We call this the head. Now, this clue holds two things. First, a piece of treasure. That's your data, maybe a song title. But the second thing is the important part. It has a map, or a pointer, that tells you exactly where the next clue is hidden. So you follow the map, find the next clue, and guess what? It's got its own treasure and its own map. You just keep doing that over and over until the very last clue has a map that just says the end. And each one of these clues, that's what we call a node.
And this brings us to the #1 rule of our treasure hunt. You have to follow the chain. You can't just jump to the 5th clue. Nope. You have to start at the beginning and visit every single one, in order, link by link.
So you might be thinking, why bother with this whole treasure hunt thing? Why not just write it all down on one big list? Well, that's where the real genius of this idea shines through. Let's compare our chain to a more, let's say, rigid kind of list. Okay, so think about a normal static list, what programmers usually call an array. It's kind of like a grocery list written out on paper, right? If you want to add an item smack in the middle, you have to get out your eraser, rub out everything below it, and rewrite the entire bottom half of the list just to make room. It's super clunky. But with our linked list, our chain of clues, it's so much slicker. You want to add a new clue? No problem. You just do this little trick. You find the clue right before where you want to add the new one. You change its map so it points to your new clue, and then you make your new clue's map point to the one that used to be next. That's it. You're done. No mass erasing, no rewriting the whole thing. It is just pure flexibility.
And because they're so flexible, linked lists let you pull off some really elegant solutions to some pretty tricky problems. Let's check out one of the most famous tricks in the book, something that's often called the tortoise and hare algorithm.
So here's the puzzle for you. Imagine our treasure hunt chain is, well, you don't know how long it is. It could have 10 clues, it could have 10,000. How in the world could you find the exact middle clue by only going through it one time? You can't count them all first, that's cheating. The answer is just beautiful. What you do is you send two walkers down the chain from the very beginning. One is a slow walker, our tortoise, who moves one clue at a time. The other is a fast runner, the hare, who jumps 2 clues at a time. So watch this. They both start at node 1. In the first move, the tortoise goes to 2, but the hare leaps all the way to 3. Okay, next move. The tortoise plods along with 3, and the hare jumps to 5. And stop. The hare hit the end of the line. Now let's look back. Where's our slow and steady tortoise? It's sitting right at node 3. The exact middle. It's an amazing trick. By the time the fast runner finishes the race, the slow walker is always at the halfway point. And hey, quick little bonus for you. This exact same tortoise and hare method, you can use it to find out if the treasure hunt is a trap, if it leads you into an infinite loop that goes around in a circle forever. How? Well, if you're in a loop, the fast runner is eventually going to lap the slow one. The moment they're on the same clue, you know you're stuck. So finding the middle is a really cool trick, for sure. But the linked list is not a one-trick pony. Not at all. It's a foundational tool that's used to build all kinds of other powerful things. For starters, you can reverse the whole chain. The trick here is to think of it like you have 3 hands. One hand points to the node you just finished reversing. A second hand is holding the current node you're working on, and your third hand is out in front, holding on to the next node in the original chain so you don't lose your spot. You just walk down the line, passing nodes between these 3 hands, flipping each pointer as you go. You can reverse the entire list in one single pass. You can also do this really elegant merge. Let's say you have 2 lists that are already sorted. Think of it like 2 lines of students,
each one already sorted by height. How do you combine them into one big sorted line? It's easy. You just look at the person at the front of each line, pick the shorter of the two, and tell them to go next. You just keep doing that. Compare the two at the front, pick the smaller one, and you repeat that until one of the lines is totally empty. Then you just tell the rest of the other line to tag on to the end. It's so efficient.
And to get a little more advanced, it's a key ingredient in building something called an LRU cache. Now, LRU just stands for least recently used. This is the kind of thing your web browser uses to keep frequently used stuff handy. And it works by combining our linked list, which tracks the order of when you use things, with something called a hash map, which is basically like a super fast digital phone book. Every time you use an item, it jumps to the very front of our linked list. And when the cache gets full and needs to make room, it just looks at the list and kicks out whatever is at the very, very end, the thing you've used least recently.
So, here's the main takeaway. All this amazing stuff, reordering your songs, finding the middle of a huge list, building these high-speed caches, it all comes down to one single, incredibly simple, but powerful idea.
It really is just that, a simple chain of pointers. But it enables all of these complex and really clever solutions. The power isn't about storing data in one big, rigid block. It's about the relationships, the pointers, the links between all the little pieces.
So the next time you drag a song in a playlist or hit undo in a document, you can kind of smile, knowing about the little digital treasure hunt that's happening under the hood. It's a truly fundamental piece of the puzzle that makes our digital world feel so smooth.
And that really just leaves us with one last thought. It makes you wonder, doesn't it? What other simple, elegant ideas like this are out there, hiding just beneath the surface, just waiting to unlock these incredibly powerful solutions to problems we haven't even thought of yet? Thanks for joining me.